Hello, hello. Welcome to the stream. Uh, just give me a moment to get ready. As usual. Yeah. Yesterday's stream was a bit chaotic. Um, it got into a rabbit hole about standard string sizes in different compilers, C++, I mean, and also pushing const expert to the limits. Yeah. Okay, just give me a few more moments. Okay, I think I can begin. So, I just saw some mail. I'm sorry. Okay, I think I can start. Well, here we go. Welcome to the stream. Yesterday I wanted to show off a little bit of Shakedown Engine, and yeah, I started talking about why Zig, why a new project. You know, this is kind of going to be a weekend project. I'm gonna do it on and off, although this is not a weekend, it's Monday, but it's night, so I was working the whole day on other projects, and I was like, okay, I have like 1 hour or so left before I go to sleep, so maybe I can do some streaming as well. And since my brain is still in Zig mode, then it's easiest to just continue with Zig. Is sound okay and everything? I think it is. So yeah, I was talking about why Zig. I did post a little image of why on Twitter as well, which I actually have here. Right, that there's no header files, fast compile times, integrated build systems that I was showing off, easy testing, powerful metaprogramming with Comptime, similar to C with less foot guns. It's definitely not like C++. It's simple, like easy to learn. You literally need like a week to get a hang of it. And yeah, it can compile both C and C++. You can literally use the Zig build system as a C++ compiler as well. You can use C headers directly. And well, yeah, I didn't mention it yesterday, but I've added that it also has a package manager now, with 0.11 update, it has a package manager, which is, it is interesting, the choice they made, how to do a package manager with an entire code hash and everything, which they're kind of, the vibe that I get with Zig is that they want to really make a language for the next like 40 years. So they look at all the package managers and they say, well, it's shit. Let's make sure that something is robust and it's going to work for a long time, which is something I appreciate. And so I talked about this yesterday, and also I mentioned there's another hidden area. Why not Zig, right? I would need to rewrite everything. I have a game working in C++, but hopefully rewriting everything in Zig will make me it will make me faster. Well, lack of libraries, maybe. I say maybe because, well, most of the libraries I use are kind of C compatible. So maybe I can just use them as C headers. Although some of them, like bullet, although I don't need to use physics, I don't need to use bullet physics in my Zig engine. I haven't actually looked into physics yet. But what I know that works is like GLFW, OpenGL works. I tried stuff like that, and I want to write that on stream as well. Okay, and one thing is that not knowing the language that well, there's still some things which kind of confuse me a bit, although I did say that it's a simple language, and I just said that you can learn it in like a week. Well, you still need time to master it, right? But it definitely is not like super difficult, right? It's not like Rust where you have this you start learning Rust and you're like, oh, this is going fine, and then you just hit this unsurmountable cliff that you have to go over. That's not Zig at all. Like Zig has quirks, but the slope is very how do I say, very shallow, very it's a very low angle, so you're learning as you go. Which is very nice. Okay, so yeah, I wanted to also, at the end of the stream, I was also showing off Zig, which is this. I've managed to get, I managed to show just a few things. The fact that you can't have uninitialized variables, but if you do want uninitialized variables, you have to explicitly say that they're undefined, and then they will be uninitialized. But that's the thing. It's like it avoids the C foot gun of just defining a variable, declaring a variable, and you have no idea what this what the value is. But in Zig, you have to do that explicitly. Another thing is that it has const variables and var variables, which are mutable. And then I also showed off how you would do initialization with structs. You have to initialize everything in a struct, but actually you can assign a value for your members. And I also mentioned quickly that you notice that this is an F32, this is an I32, right? A 32-bit integer, but this one is I31 because Zig actually has arbitrary length integers, and I'm going to show an example a bit later why this is important, because you can do funky stuff with that. But yeah, I just wrote this because I want to show off, like, oh, look, you can actually do that. But yeah, anything that you nest, you have to initialize as well. And then if you already have initialized variables, you can initialize it with just, defaults. If you have something that you didn't initialize in the struct definition itself, it will complain and it will say, wait a minute, you have to explicitly, okay, let me just start the terminal What is going on? Okay, it took some time. Yeah, you can see here that my struct has become red because it's missing struct field F, right? You have to initialize field F. And this is why Zig is cool, right? It doesn't let you not initialize. Okay, so yeah, this is the only thing I managed to show off yesterday in Zig, because I think probably half of the stream was spent complaining about why things break in C++. How it has like 5 different levels of metaprogramming, and then I was showing off const expr, and then somebody on the stream came and was like, wait, how does const expr work? What if you do recursion? And so we went down the rabbit hole of trying to make recursive functions with const expr, which we realized that it depends on your stack size, and it will break at 512 iterations. So as long as you have at least for the Fibonacci, with a simple Fibonacci, as long as you have like 511, you can probably extend stuff like that, but it will not do. At some point, it will fail, and it has some weird ways how it fails. Anyway, it was interesting, but I was interested myself, right? I'm not blaming the guy who was, or a girl who was asking about const expr, because I was actually interested as well. I just, the problem is that I went too far, and then we were in the rabbit hole of not doing Zig on stream. Okay, so today I want to show off, by the way, I wanted to say also that I kind of wanted to actually go over how Shakedown Engine works, and then kind of make a little structure in Zig about like recreating the Shakedown Engine sort of. But yeah, I didn't have time for that, and while I was showing off Zig here, I actually got really tired and I wanted to sleep. So so today, instead of doing this, right, instead of the Shakedown Engine libraries, I want to show off a little bit of Zig, a little bit more of Zig, right? A few cool features that Zig has that I really like, and this time I'm a little bit more prepared, unlike yesterday, because I've actually tried all of this, and now I'm going to demonstrate live. But yeah, this is something that is quite cool about Zig. Yeah, so I forgot. I wanted to say something else, and now I forgot. The thought escaped me. Oh yeah, I wanted to also make it so that one thing before we start, every time I wanted to compile, I actually did this, right? I did a Zig build run, and then I did a run, but I actually want to make it automated a little bit. So I'm actually going to copy, stupid test. Okay, I'm going to copy from a stupid test into the stream demo this VS Code folder. And what this one has is that it has some tasks. And right now I have a build task. So yeah, so what I want to do with this is that now I don't need to go into the terminal, do this. I can just say Control-Shift-B, and there it is. It will actually execute the task. I don't have to go into the terminal because I've made the task here. And there's also a test task, although I don't actually know how to run this. Yeah. So, well, right now I'm just gonna use the main. Hello, Anton Makes Games. Nice to see you again. yeah, so I was telling yesterday that Zig doesn't have function. No, how do you say this? Function overloads, not overloads, but it doesn't have arbitrary. No, the name escaped me. What's the name of it? When you can have arbitrary number of parameters, right? Or have multiple functions with the same name, right? It doesn't have that. So it's following the kind of the C simplicity of just not having that, because function overloads are they're a huge problem. And I've seen multiple talks at like CPPCon, not like live, but online, just about this problem, right? About like, okay, what if you have multiple functions with the same name? How do you resolve this? And this is kind of what I appreciate about Zig, because it just goes like, well, this is a huge problem. We're just not going to deal with it. Let's not do that, for simplicity's sake. So, but it has a lot of features that you can do. For example, in the case of a log info, right? If you just want to submit some log, and you say, hello world, you still have to have this anonymous tuple over here, even if it's doing nothing, right? But because it doesn't support this, because the function signature, it expects 2 arguments. It's gonna say now, expects 2 arguments, found 1, right? Because there are no, in C++, instead of saying expected 2 arguments, found 1, it will say there's no function overload that accepts arguments of types this and that, right? And this can actually be pretty annoying error message in C++, because a lot of times you just put a wrong argument or something, but it will actually complain about there's no other function overload, which is really weird, because I would like to be warned about incorrect things that I've put into it, and not about non-existing similar functions. This is just a little thing that I wanted to say in the beginning. Okay, but let's go over the stuff that I wrote. So I'm just going to continue writing here. So, by the way, for the people watching the stream, have you tried Zig? And what do you think about it? The person who I chatted yesterday on the stream said that like it kind of isn't, for somebody who is like a C++ guy, it doesn't really make sense, like where does Zig fit. That's what I actually heard a lot about. Like they don't know where does Zig fit in like the modern landscape of languages, which I disagree. I feel like it's the new C. That's how I really feel, because it's just so much better. It's just so much less pain. But yeah, if you're programming in C for such a long time, then you probably don't want to change your habits. First time I've heard about it. Is it now that you heard about it for the first time? It is actually pretty simple, and just go to Ziglang and just download it and play with it. Interesting that you only heard about it now. It also has like a single page of Zig reference. I mean, it is a huge page though. It's not just a single page, but it takes a lot of, there's a lot of explanation how things work, values, these are all the types, and stuff like that. And it has a little, but literally you can go through this in a week, and there's actually a lot of things that are not that important. I did skip a lot of the parallel stuff, like atomics and mutexes and stuff like that, because it's not that important for me, at least for my toy engine. It is pretty much going to be single-threaded. Maybe I might multi-thread, like loading meshes from disk or something, but for the actual game, it's going to be simple enough that I won't need parallel. Multiple threads. So yeah. Anyway. Yeah. The gist of I think I didn't even talk about the bit, like I just started doing like, oh yeah, this is Zig. Zig is cool, but I didn't really explain. Yeah, I didn't really say about this things that Zig, the Zig homepage would say, right? That it's about robust, optimal, and reusable software. But I mean, through what I was talking about, you can see it, and you will see it today when I explain all the stuff. But yeah, I mean, you can read it yourself. So I won't spend time on stream trying to explain the basics. What I really like about okay, this is a little bit of a funny thing, because Zig also has its own Zen, as they call it, the Zig Zen. I just remembered this, and you can actually, if you say Zig Zen, it will actually give you a little bit of a manifesto of the language, which I think is interesting. So, communicate intent precisely. Yes, I agree about that. Edge cases matter. Edge cases, this is pretty much about, about handling unexpected situations. Favor reading code over writing code. Okay. I don't know. It sounds a bit like if you don't write codes, you can't read it. Only one obvious way to do things. This is something that I really love. I think that, like if you think about any other language, there's so many ways how you can write things. There's this joke that there's this joke about C++ initialization, right? There's like 20 ways to initialize things. You have constructors, you have in-place initialization, you have those bracket initialization, you have, oh my god, it's crazy. There's even a like there's this GIF, initialization GIF of oh yes, oh my god, I can't believe I found it right away. Forrest Gump. Yeah, anyway, I was saying C++ is very flexible. You can default initialize, value initialize, zero initialize, list initialize, copy initialize, static initialization, dynamic initialization, aggregate initialization, reference initialization, constant, struct, deferred dynamic initialization, union initialization, nested initialization, direct list, copy list, explicit. Yeah, like this is ridiculous. And Zig just goes, oh yes, and initialization order fiasco as well. That's about it, but he listed like 20 ways. And yeah, like Zig says just like, no, this is how you initialize. You can either initialize in a struct by default, or you just do like, you say equals something, and that's it. Yeah, and there are no constructors, there are no destructors, right? But there are cool ways that you can do RAII without those, and I'm gonna go over it. Zig is too cool. Yeah, Zig is too cool for many initializations. Okay, anyway, yeah, so let me, oh yeah, I didn't finish the Zen, sorry. let me go over the Zen first, and then I'll go into showing off. Okay, yes, only one obvious way to do things. And of course, this doesn't mean that there is only one way to solve a problem, right? It just means that when you're writing code, the way you write code, there should be only one way to write code, right? And not, of course, every problem can have multiple solutions. That's not what it means. It means when you're actually typing, right? There shouldn't be too many ways to do the same thing. Runtime crashes are better than bugs. Yes. Compile errors are better than runtime crashes. Absolutely. Incremental improvements. Yeah, so Zig has this, like every new version is incrementally improving it a bit. And of course, not only that, but your code should incrementally improve. Avoid local maximums, reduce the amount one must remember. Yes, this is kind of a C++ thing as well, where they're adding so many things that I keep forgetting. Focus on code rather than style. Yes, this is one of the things that when you install Zig, it actually kind of forces you to use its own formatting style. And it will always format your code. I was talking yesterday about if you just don't have a comma, it will actually inline like this. And if you put a comma at the end of a struct member, it will, And I actually really love this, because if you have a super small struct, you can inline it. But this is the only kind of leeway it gives you. And everything else is pretty much just, you have to always respect its guidelines. And I like that because, well, two reasons, right? You're not spending your energy on style, on styling your code, right? I'm just spending my energy on writing. And another thing is that I can totally read everybody else's Zig code because it just looks the same, and I don't have to think about, like, what is this going on? Why is this why somebody puts template in the same line and somebody in above, and then you put inline here, and what the hell is going on? I'm talking about C++. Zig just says no. Everybody has the same style, and let's just not waste energy on it. I also want to try Zig at some point. Hello, Marcus Don, by the way. I also want to try Zig at some point. Let's see how you enjoy it or suffer it. Yeah, there's definitely going to be a little bit of suffering, right? But so far, I'm enjoying it. Resource allocation may fail. Resource deallocation must succeed. I really like this one as well, because it is using an error union whenever you need to allocate things, which is something that I'm going to show today. Memory is a resource. Yes, absolutely. Together we serve the users. Is this an accidental duplicate, or I don't know? It's a little bit of a Borg sounding, but yeah, I'll go with it. So yeah, that's what happens when you type in zigzen. Anyway, let's go over a few things that I really love about Zig. So here is a list. Yeah, so I as I was kind of rehearsing for this stream, I typed in a few things and I tried it, and yeah, I think this is kind of it's not a great sequence, but here we go. So the first stuff, any type is sort of a inference. Well, this is actually continues on yesterday, because I was talking about it yesterday. If you have a if you have a function that returns, it could be an add function. You have one number, which is i32. You have another number, which is i32. And this is, it returns i32. you can return the sum of the two numbers, right? And you say, well, here we go. I have, let's have a C, and it's going to be an add. And yeah, I can actually put a and B since we already have them. But let's see if actually it works, because A is a Comptime int. Because when you define a const A, a const variable, it becomes a Comptime int, because const is very similar to in C, C++ define. So it's almost like as if I wrote define A0, right? And yeah, no semicolon at the end of macro. But yeah, this is basically what this is, right? But at the same time, it is also similar to a const expr, right? A equals 0. But it's also similar to const A0. Sorry, const expr, it would be like int or something. So yeah, Zig just says, no, there's only one way to make a constant. And if you would define it here, right, then it would be basically compile time known. This means that because it's in a function, it is not compile time. It is, well, actually it is here. But if you would assign it to another number, it would just be a read only. And yeah, let's see what it says. Yes, use if undeclared variable. I've just removed it. Okay, so this is going to build. Let's see. It did build. Interesting. So I did actually manage to pass it. It has automatically. So it has automatically implicitly converted to an I32. I'm pretty sure, because this takes an I32. Okay, but what if I want to add two floats, right? What if I want to float add, right? This is classic, I don't know, doing this. And of course it doesn't work. Oh yeah, this is unused. But let's also do this const. Okay, well, fractional components prevent floats values from coercing to type I32. Oh, interesting error. Like, you cannot coerce a float value. That makes sense, but I really like this error because I wouldn't expect it in a different language, right? So yeah, it can't coerce to an I32, and then we have this error. So what we can do is we can try. Okay, let me try this. Maybe it's not going to work. If I do any type, if I say that A is an any type, but here is a bit of weirdness, because I can't actually make any type as a return value. But I can take a type of A, right? But I can also do a type of A plus B. So that this is kind of like decal spec in C++, right? You can say, what is the type of a sum of this, and then return that. Although in C++ you can also use auto, and auto will just infer a return variable. And so this kind of becomes a template, right? Because suddenly, there it is, I can add two floats, and it becomes an unknown. Well, the language, what's the name of it? ZLS, the language server. The language server doesn't know what the type is, but yeah, the Zig does know, because I think this is Comptime, so it doesn't have very good type inference. Figuring out type at the time of how do you say autocomplete, right? So let's try to build it again. Let's see if it works. Yep, it does work, although I'm not using this at all. So let's see how much is this, right? If I say, okay, Meister, what is this Meister? Oh, that is actually the struct. So let's move that here. And let's try reading the results of a float add. I'm just gonna do this. And I'm gonna float add. Yeah, okay, let's see how this goes. How much is it? 3.4 plus 4.3 is 7.7. Cool. Yeah, so as you can see, you can kind of make templates with this. There is another way that you can do, and that is to explicitly pass a type. And to explicitly pass a type, you need to use a Comptime keyword. So a Comptime A is, yeah, so actually I'm going to show this on generics, right? If you want to have like a generic list for a type, you can have it. And yeah, I'm going to actually show it later. But yeah, this is how you can do like stuff like that. And for example, one other thing is you may have noticed that oh, by the way, Marcus Dunn, I missed your question. What happens if the types you use in the call don't have the plus operator? Another thing about Zig is that it actually doesn't have operator overloading, right? But it only works, these addition, subtraction, division only works on basic types. So it's either floats and integers, basically. So if it doesn't work, well, it will give you an error. But let's see what, if I try to do it on yeah, actually, let's see what happens if I add an integer to a float. It's probably going to be converted to a float. Float and int add. Float, yeah, well, this is terrible. And int add. Let's do a 3, 4.5, something like this. Okay, well, this is not used, but let's see if it builds. Yeah, of course it builds, but let's see what's the result. Float and int. Float and int. Interesting. Oh no, this is actually a, yeah, this happens sometimes. Unable to update file. This happens because I think the ZLS, the Zig language server, is working on the files at the same time or something, so it can't write. But so sometimes you have to just build twice and it will work the second time. So there you go. It becomes a float, obviously, 7.5. So yeah, it will convert into a float. But let's see what happens if we try to float and string. Okay, I try to do a float and then I do like a string. Let's see what happens now. Incompatible types, compatible Comptime float and const 8 UA. Yeah, so string types are a bit weird. I am going to explain them later. But you know, this is a string, just so you know. Yeah, there it is. It says type of A plus B. Nope, incompatible types. You can't add them. So yeah, there we go. You can't do that. And it will actually propagate the errors, so you can see where. Can we actually see where it's used for the first time? Debug native. No, this is the previous problem. No? Is it? Okay. No, it only shows me the place where I am attempting to add incompatible. It's interesting that it actually matches, problem matches here and not actually here. This would be great. This would be cool if it would actually tell me here and not over here. That's kind of a similar problem with C++ templates though, because they will always error in the template itself. And if you have nested templates and the error is somewhere super deep, good luck, you know. Good luck finding out where it comes from. So yeah, it would be cool if it errored actually here and pointed me into the, oh no, you can't pass these two arguments instead of here. Okay, but yeah, obviously you can't do that. I thought that all the promotions should be explicit in Zig. I think at the point of, I think when you're passing into a function, they do coerce. So if you have a, yeah, actually I'm gonna get into that. I had this problem when I was, yeah. So one thing I want to show also about AnyType is that you see when I am actually outputting this info, and when I am showing the, yeah, when I, for example, how does this function work? How does the info function work? Because it has args, which are AnyType. You can see that they're AnyType, which is exactly what we want. And what I'm trying to show off as well. But here's the thing. You know, this one has a length of 2, obviously, and it will just work, and I can make it any length. You know, I can add many of them, and it will need to be 5 times. But here I have 1. So how does it know that this AnyType, which is an anonymous struct, well, anonymous struct is basically a tuple. It is a tuple. And so when I send it into a function, what actually happens? How does it format this, right? Well, here, let's try to make a kind of a format ourselves. But let's make it for each new line. So for each parameter I pass, I want to make a new line. And yeah, for example, let's call it just log. And I'm going to, or let's say log new line. And for that thing, I'm just going to accept one thing, and I'm going to call it args, which is going to be AnyType. And it's going to be void because it's going to output itself. It's not returning anything. And here's the thing. This could be any length. It's going to be a tuple of any length. And if I do a log new line, and I just, you know, I just say here, I'm going to say 1, 2, 3, right? What I can do, this becomes now a tuple of 3 elements. But here is where Zig is pretty powerful, right? It accepts a tuple, and what we can do is we can do a lot of cool, actually, reflection at compile time. So this, we can actually go through, we can loop through elements of a struct. But now I have to remember how. You can actually loop through them by saying args. Yeah, wait, I actually have to remember now. I'm too ahead of myself. If I have a var tuple, which is like 1, 2, and what is actually the, can I, no, okay. I think I can actually capture it directly. Let's see. Let's see if I can for loop through all the arguments. So I take the args and I'm gonna capture, and by the way, this is this is basically like a for each. But what is interesting about it is that it's a bit different than in other languages, right? You put in other languages like C++, you do a for loop and you say arg in args, or no, wait, in C, is it in C++ is like this, right? Arg in args. In C#, it's for each arg in args, right? But in Zig, you actually put the elements later, afterwards, and it uses special the bar brackets, and why is that? Because it considers this a capture, and at first I really didn't like this. I really prefer this kind of like this and that instead of take an element and loop through it. Take an element later, but actually it makes sense because captures are everywhere, and Zig has a lot of ways how you can capture elements. You can capture them in ifs from optionals, you can capture them in errors, you can capture them in for loops like this, you can capture them in while loops as well. And once you see all the ways that you can capture things, it actually makes sense. And I actually really like this idea that the capture is a separate thing. And yeah, if we go through each of the arguments, and now let's try to do something like this, but I'm not actually sure if this is going to work. I'm just going to do an arg. And I think this is not going to work because, so here is the thing. Unable to resolve compile time value. Tuple field access index must be compile time known. And this is interesting. This is very interesting. Because each instance of this, it totally depends. The instance of this function depends on what the type is. That's what it means, right? Because what happened in this case? What happened in the add? A plus B, right? We had two integers. In one case, we had two integers. In one case, we had a float, two floats, and we had in the third case, we had integer and a float. And what happens here is that any type will actually create functions for you. One for the two integers, one for two floats. And I'm not actually sure if the integer and float, is it the same as floats? They just coerce to a float? Maybe it is. I don't know. But the point is that similar to C++ templates, it will actually instantiate a new function for you. And this is what actually happens here as well, because args, depending on the arguments, right? It could be log new line, and I can just pass two numbers. And this is going to be a completely new function type because it has different type. The arguments are now a different type. But here's the thing. I can't just for loop because this is not dynamic. I can't do that at runtime, basically. I can't loop through a tuple at runtime because it needs to be compile time known. And here is the thing. Zig has a little thing that's called an inline for loop. And what inline for loop does is that it literally unrolls the loop. So if you add an inline keyword, now this becomes literally this, right? It becomes this. Args 0, args 1, args 2, right? That's what it becomes. And this is incredibly cool because you explicitly in C++, the compiler will sometimes try to be smart, and try to inline it for you. But in Zig, you can explicitly inline, and you're absolutely sure that this is just going to unroll your loop. And first, you can do it for optimization, for vectors or something. But secondly, you just have to use it for Comptime because it needs to be known at Comptime, at compile time. So now, if we try to run this, there we go. We got a, and you can see. Wait, I can say log info outputting args, something like that, right? And so that I have at least, I can see the difference between the two function calls. And there we go. We have one function calls outputting args with 2 elements, and the second with 2 other elements. So that's pretty cool, right? But the cool thing is, this is not an array. This is a tuple. So this could be anything, any type, right? It can be, it could be float. It could be a string, although, okay, well, here, let me show you that it can be a string first, right? It will update, there you go. This is an integer, this is a float. Clearly, it has a different, if I had another thing which had an integer, this would be 2 separate functions. They just created it at compile time, which is pretty cool. There you go. But here is another thing. Here is a little bit of a weirdness, right? What if I put a string, right? This is a string. This is a string, right? There's actually going to be an error because here is the problem. I can't output an array without a format specifier. So in this case, right, if I want to output a string, if I want to output a string like this, this is output a string here. And if I try to do this, sorry, I need to do a tuple, and damn it, I'm terrible at editing text. Cool, right? I want to output cool. It will say, nope, you can't do that because you need a format specifier, and the format specifier is an S. Or if you want to output a pointer, then you have to do. And this is because this is actually a compile time string, which is actually in the how do you say it? I forgot. Oh my god. The part of the memory where all the strings reside, which are compile time known. It's the same thing in string in Zig as well. Sorry, in C as well. Yeah, you can't. Yeah, now it works. Right there it is. Output string here. Cool. Okay. So what do we do in this case? What do we do in this case if we do want to include a string? Well, I need to figure out that. I need to figure out that it is a string. And how do I do that? Well, I actually have no idea. You can test by getting a type, and you can say if type of arg is, and now I can do a u8 const u8 because this is a const slice. Well, I'm going to talk about slices a bit later. And if I check this, I am going to see that this needs to be a S, otherwise it's going to be this. Oh wait, yeah, of course. In Zig you need to have brackets for everything, which I don't complain about. What is this? Why is it complaining? Okay, there we go. Okay, so let's try this. Let's try if the type is, well, okay, it doesn't work because the type of this is not actually a slice, and this is a little bit of a problem. I'm passing actually an array of there. Let's try this. Let's try outputting a type as well. So I'm gonna say, oh yeah, well, it's gonna break because it doesn't work like that. Yeah, let's try to get a type of, like, okay, hear this. I'm gonna output, let's do a log info like this. I'm gonna output a type of my string, and this is gonna be an S. And I'm gonna make a string, and I'm gonna say type name. And this will convert it into a string. And I think you can actually even output a, this function returns a string of, okay, what does it say? Expected type found const. Oh, there you go. It actually, this is what I was actually looking for. It actually says that this is a const. Wait a minute, I could have done this as well. No? Const stir is stir. And then it would have told me, right? Yeah, exactly. Yeah, I'm stupid. I didn't have to output it. Okay, yes. As you can see, the type of stir, if you just define it like this, is a const pointer, a pointer to the array of U3. And what is this? This looks weird, right? What does this mean? And I said that strings are weird, but once you get it, it's actually pretty easy. 3 means the number of characters, right? It has 3 characters. It's a array of size 3, and this colon 0 means that it is null terminated. It terminates with 0, right? So there's 3 elements and there's a 0 at the end, and you can actually make any array null terminated. So if I wanted to make a const, if I wanted to make a an array of, I don't know, if I want to make an array of numbers, right? I say numbers, and the numbers are U8, and it's a bunch of numbers, right? And well, first off, what is this? This means infer the number of elements. I could have actually written 4 as well, but this just infers the number. But I could have also said this. I could have said 0, and that means this array will actually terminate with a 0. So there's actually a hidden 0 here, which is how Zig handles basically compatibility with C and other stuff. By making a character arrays terminate with 0. But here's the thing. What you can do is you can actually, if you have a string, right? If you have a string, let's have a string of str, right? As I said, this is a const of 3. It is this weird signature. That's the type. But you can also cast it into a slice. So if I say stir slice, and I'm going to make a stir, but the type of it is actually going to be a U8 const U8. Wait, does this work? No. How can I actually cast? Oh yeah, well, the thing is that I think I need this, because no. Expected type confounds const. Okay, maybe I don't need to do this. Yeah, right. It will automatically, because this is already a pointer to an array, so it will actually cast into a const. So yeah, as you can see, this now becomes well, I don't know why it's not showing me, but this becomes a slice. when you have two brackets, square brackets together, without any numbers in between, or an underscore, this is actually a slice, which is a pointer to a string. And this is how you can handle arbitrary number arbitrary sizes of character strings, right? So that you can pass any size of a string. You still need to store. If you are storing it on the stack, of course, you need to have predefined size of your string, but you can pass it around into functions as a slice. And this is what in modern C++ is a string view, for example. I recently did a stream. I mean, I say recently, but it was like 2 or 3 months ago. I can't remember, where I was converting my stuff to string views. So in Zig, this is basically a string view. It's not a special. It's actually built into the engine. It's built into the language. It's not, it's not a library thing that came in C++ 23 or 20 or whenever. So it exists from the beginning, and that's pretty cool. So why am I doing any of this? Because I can pass this string as a const u8 slice. And how can I do that? Well, I can just call it an as. As is basically a cast in Zig. So in C, you would do something like this, right? You would just put a cast as in parentheses, but in Zig you call a built-in function as, and you give it a type, and I'm gonna say as const u8, and then the second one is this, and there we go. And hopefully this will work. Let me remove all this because we don't need it. Zig build run, and it doesn't work. What does it say? Oh, this is a transitive failure again. Okay, I'm gonna build again. There we go. Look at that. We have outputted 1.23, and then this is a string. There we go. Because our function now can take in strings, and it understands that if the type is a slice of const u8, then it will use this version. And this is actually Comptime resolved. So this is not a dynamic if. This actually happens as Comptime because we're using typeoffs. Cool. So there we go. Any type, pretty cool feature. Done. And also, I already showed inline 4 in the examples of where you have to use Comptime features, right? So, okay. And yeah, one more thing that I wanted to show about Comptime is generics. Let's say that I want to create a, something that will, some container that will take in any type, but it needs to hold the type, right? What you can do then is you can pass a type. This is which is super powerful about Zig, is that type is a type itself, but only at compile time. So you can pass the type around at compile time. What I mean by that, right? If I want to say generic function, and I can say comptime, and I can pass a type as, well, I'm going to call it t, right? And that's going to be a type of type, right? So the type is a type itself. It is kind of confusing, but it will make sense very soon. So this thing is very, very similar to what in C++ you would create a template, right? You would create a template of type name t, this is basically it. Just in Zig, you write Comptime T and type. And as we have seen, you could have an any type, but if you want to explicitly pass a type, you can do it like this. And this only works at compile time. So for each new type, it will actually create, similar to any type, it will actually create new instances for each of the functions. Yeah, and then, I don't know, what can we do with the type? I am not actually sure. Unless we create a new type ourselves. Do you have any examples? Oh yeah, by the way, functions in Zig should be camel case. Do you have any idea what I can do with a with a templated type? I don't have an idea, except making a generic struct. So yeah, I did show you that you can make a struct. Yeah, the struct struct syntax is a little bit weird, right? Because you have a const and you define kind of a name. Like structs are actually anonymous, kind of, if you just look at this, right? But you assign it to a name, and then it becomes a named struct. And then you can have anything you want here, right? You can have a or a B, right? As I showed above as well. But here is the thing. What's really is interesting about Zig is that you could actually, if you have a generic function that takes a comp time, you could return a struct. This is where it becomes a little bit funky, right? When you think about it. You could return a struct that contains a type of something T, right? You can say my number, right? Well, it doesn't need to be a number. It can be anything. Let's call it a something T, right? And now, what happens here is this is actually going to return a new struct, right? It's going to. This is basically how you do generics in Zig. But what is powerful about it is that generics don't really exist, right? They don't exist as a concept in Zig. But because you can pass a type around as a type at compile time, you can do things like this. And you can return a struct that contains your type, which is incredibly powerful. And let's say that I don't know what this struct could be. Let's say that I want to have like an array of 3 types or whatever. Maybe something like this, right? I want to have an array of 3s, and yeah, if I want to create this, then I can say, oh yeah, by the way, if you're returning a struct, then it is usually suggested that you start with a capital in this case. So let's call it 3 of something. 3 of something, and I'm gonna create 3 of something, which is completely crazy. But yeah, I mean, this is how you create, for example, containers, right? You could have lists, and now I can't remember any of other containers. Linked lists, dictionaries, hash tables, whatever you want. This is how you actually create them. And then I can just simply say a var 3s is 3 of somethings, and then what I do is I pass a type. I say I32, and well, I do actually need to initialize it because probably the compiler is going to complain, wait a minute, you haven't initialized it. There we go. Function return type declared here. Oh, it is actually returning a nothing. I completely forgot. Well, I do need to return a type, which is a struct. Oh, wait a minute. This is a custom struct. So it's not the type, it's actually the struct. And I can't remember how you actually do it. I think you actually need to define a type. Maybe like this. Let's see. Const struct is struct. Maybe I can do like this, and then I can pass it as a struct. No, it doesn't actually know that. What if I do a type of struct? Return struct. Whoops. It doesn't understand this. Undeclared identifier struct. I can't remember how you actually do this. Okay, let me check on the example of an array list, which is basically the Zig's version of list or vector. C++, they would call it a vector. Because that's basically what you get here, right? You actually just pass it. You just actually return a type. Okay. Yes, of course. It does make sense because the type is unknown and it can be any type. So there we go. I can just do it like this. Return a struct. Okay, there we go. Did I forget something? No, this is it. Okay, so I think there's going to be a warning because this is not initialized. Variable of type must be const or comptime. Variable of type. Of course, this is a type. This is not a variable. A type would be if I would initialize it. And I do have to initialize it something like this. And this is going to be, well, 1, 2, 3. Right? I think. No. Okay, it doesn't let me do this. Okay, I'm going to expected. Okay. Oh yeah, right. I need to actually pass it as an. Well, this is kind of ridiculous because I still need to initialize it, right? Okay, let's try to actually create an empty. And instead, I'm going to create. I mean, this is kind of a weird situation where I'm actually creating an array of threes. You wouldn't actually do that, but yeah, this is. Let's just do an undefined. I just want to make it compile. That's my point. What does it say? Okay, yeah, there it is. There it is. It works. So yeah, it has actually created an instance and then also it has created a class basically, or a struct that uses the type of i32, and then I create an instance of it with this, right, without initializing it. So now I would need to, I could take a threes and something and then, initialize it to whatever I want. But I could also write a function that initializes it or something, right? I could say, well, init threes, something like that, and then I will have A, B, and C, and they're going to be i32. Well, not i32. They're going to be types, right? That I'm going to pass in. And yeah, it's going to be, well, the thing is that if you have a struct, you need to, the way you do member functions in Zig is a bit weird. I mean, it's not weird, it makes sense. Just let me say it. The way you do it is that, here's the thing, Zig doesn't like the word member functions. Or methods. It says No, these are not methods. These are namespaced functions, right? It's kind of like they look at structs as namespaces, basically. And then if you want to reference itself, you need to use a special key, a special built-in, which is called a self. And with this one, you can actually reference itself. So we can have a self that is a self. And then what we can do is we can say self something 0 is A, self something 1 is B, self something 2 is C, right? Well, I mean, this is a terrible example, so you wouldn't really do this. Just making 3 members of an array, but I'm trying to just show off that you can do these things in Zig. Wait, what is going on here? Do I need to do this? No. The expected parameter list found comma. Oh yeah. Yes, you do actually need to have this. I completely forgot. But by convention, I've seen, I don't know why Zig does this, but I've seen that people do, all the standard library and everybody else, it seems, that uses this convention, which is instead of using a self like this, invalid built-in function. Okay, wait, I'm getting something wrong. Oh, it is not a self, it is a this. I forgot about that. Yeah, it's not a self, it's a this. So this is how you get a self. But here's the thing, when you call it on the struct, it will actually be inferred. So it will seem as you're calling only the 3 functions. Although there is a little bit of a problem here. And this problem is that I'm actually mutating this. I'm mutating something. I'm not actually using here. Yeah, here's the thing. In Zig, every parameter is actually constant. So unlike in C++, where you have to explicitly say this is a const, this is a const, this is a const. In Zig, they're all consts. They're all consts by default. So how do you actually mutate a value? Well, you mutate the value by passing a pointer. So if you say that this is actually a pointer, if I'm not mistaken, no, actually that's not how you do it. You do it like this. This is a pointer to this. And then we can actually mutate it, but we have to dereference it. So to dereference, you put a star after a dot. So that is how you do it. And then we can actually mutate it. There we go. And this should hopefully work, right? Now I can say, instead of this, I can say 3s, init 3s, and I can pass 0, 1, 2, for example. For example, this is a stupid example, but yeah, what does it say? Consider using try catcher if error is ignored. Ah, that is because of this. Because I have an error, but it shouldn't really be an error. Okay, so let's see if this works. Zig run, there it is, it totally works. So we have, in this case, we have created a new type that uses an i32, and we have initialized its 3 array values. Completely doesn't make any sense. Why would you have this array of 3? It doesn't matter, it's just an example. But here's the thing, we could have anything else. We could have 3, let's do a 3 strings. Why not? Let's go for the difficult. And now I'm gonna have it as a const u8 slice, right? Because why not? And I'm just gonna initialize it to this, and we can have 3 strings, init 3s, and first, let's do second, and let's do third. And there we go. We have a generic class that doesn't work. Unable to update file. Okay, this is this transitive error. There it is. It works. It compiles. There it is. We have created a single generic class. Well, it's blasphemy to say class. It is a struct that returns a struct. So it creates a new struct where you don't know what the type is, but you can pass in a type, and it will create an array of 3 things where you can set with the function. So this is kind of like template metaprogramming, but much nicer, much nicer. Okay, there we go. This is really powerful Comptime features of Zig. And it's not just that, right? There's a lot more things. You can get type infos. You can loop through structs, which is amazing. This is something you can't do in C++. There is actually a crazy way how to do it with Spin and stuff, but it's crazy. Loop through struct Zig. I think there is actually an example. Iterate over. Look. This is how you do it in Zig. And C++ can't do it for 50 years. It's not 50 years. I'm sorry. Yeah, there we go. You just say inline 4 std meta fields. I think that they have actually. Does std meta fields still exist, or did they change it? Std meta fields. Oh yeah, it does. So it will actually return. Oh my god, it is actually a. Yeah, it actually gives you a way how to get a fields of a type, right? And you can simply capture it. Of course, it needs to be inline 4 because it's compile time. And then you can just loop through it. You can output. This is just magic, because I spent, a few days making this CFG saver in the config list, as I call it, the config list class, where you can have where you need to register parameters, and then you have to save it and load it. This allows you to save and load in one line, and you can just add your parameters here and even use them. And my god, it's amazing, because you can loop through a struct and get the name of a field, and yeah, it's just amazing. Okay, this is when I saw this, I fell in love with Zig. This is what I wanted in C++ forever. Okay, yeah, you can get total meta programming from structs. Okay, so let's go over the next things. Comptime generics, I showed that. Arrays and slices, I did actually show that there is a difference between defining an array as a stack-based array like this. You can have an R, you can have I just remembered that I have some kvass, some drink in my freezer, and I totally forgot I put them because I wanted to cool it quickly. So let me take a break. Oh, it's actually perfect. It didn't freeze. There's no ice. Delicious. Really need some drink after just talking all this time. Okay. So, how is everybody doing? Are you enjoying so far? Let's see. There's quite a lot to go, but I did touch on things, all of these things a little bit. Just give me a moment. Okay, so let's continue with the difference between arrays and slices, right? Because if you create an is this valid actually in Zig? I don't think so. No, you need to define a type before. So of course you can have arrays, and arrays look like this. You define in your square brackets, you define a size, and you define a type afterwards, and then you can initialize it like this. But here's the thing. This can be inferred, of course, by the compiler, and you infer by putting an underscore. And now this means that this is still an array of 4 elements, but because we're initializing at this place, right, then it is, well, now it is an array of 6 elements. And you don't have to update this number, which is cool. But here is what I can do. I can create an array of, I don't know, 16 elements, right? And if I just create it, this means nothing. If I just use this, it will actually complain that I haven't initialized all elements, right? There it is. It says expected 16 array elements, found 0, right? So this is kind of annoying, right? I want to have a 16 array, elements, but I do actually want to initialize it to 0, perhaps. How do I do this? Well, here is where a little bit of weirdness comes in, but once you get it, you kind of want to have it in all the languages. Zig has 2 interesting operators. Okay, let's not do this yet. Let's have a second array, which is, by the way, if you do this, I'm not actually sure what happens. Okay, it's transitive failure. Okay, it does work. So I guess that this gets copied. Does it get copied? I'm not actually sure. What is the type? Okay. This is something that I'm not sure about. Let's check. R2 type of R2. What is it going to tell me? Type is for I32. So yes, it does actually copy, probably. So what happens if I change one of the parameters? If I place it to 10, okay. Let's do a for loop. Let's say this is an E, like an element, whoops. And then for that one, and I'm gonna do a quick for the second one. I'm just curious about this for a moment. Are these going to be, is this a copy or not? I think it is, but we'll see now. Unused arguments. Oh, right, because I forgot to put these brackets. Yes, it is a copy. It is not a reference. It is a copy. Yeah, I think it does actually copy everything by default, even arrays, which is good to know. Which is good to know. But here's the thing. Zig has interesting thing. It actually I'm gonna return this 4, and I'm gonna keep it here for now. It has a plus operator, and what plus operator does, it can concatenate two arrays, but it also only works at it only works in compile time known arrays. So yeah, did I? Oh yeah, I actually changed it. So this will concatenate two arrays. I still changed the 0, but these are going to be two same arrays. So what you can actually do is you can have a str1, which is this. You can have a hello. You can have a let's not go with hello. Let's go with foo. And much better, much less used. And you can have a bar, and then you can have a third string that is str1 plus str2, and this will actually concatenate them. And if you output it, let's remove this, and I'm gonna output this one. Wait. Yeah, let's not output the type. Instead, I'm gonna output str3, and with the string str3, let's see. There we go. Str3 is foo bar. So this is actually concatenating, but it is concatenating compile time known strings. Why is that? Because this needs to be allocated in a stack, of course. Everything is here allocated in a stack. So it needs to know what the size is of this string. But there's another interesting operator that I need to show you, and that is the wonderful asterisk or star operator. Okay, and what star operator does is that if you use it with a number, it will actually look at this. Look at this. What happens now? Ta-da! Foo 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 foo. When you use with a number, it will actually repeat. It will actually repeat an array. So it concatenates the same array multiple times. And did you now figure out yourself how to initialize an array to zeros? Well, you can simply initialize an array to zeros by creating an array that is initted to zeros by creating a single element of u8 of 0. And then I can simply repeat it 16 times. There it is. And this is how you define an array that is initialized to 0 how many times you want. It is weird, but once you understand the simplicity of it, that you have this little operator that does the magic, and you can do a lot of funky stuff with it, then you're like, oh wait, this is actually pretty cool. Because at some point, I might actually want to do like a 0, 1 or something. and repeat that. So yeah. Oh, and by the way, I don't really have to do a 1 here. I can just infer, right? But this now is 16 long. So if I would, output the R init to zeros and use an element and std log info. Right? If you would do this, you would see that I have a transitive failure. No, there it is. I have an array with everything initialized to zeros. Amazing. There is another way how you can initialize to zeros, and that is to use R init to zeros, let's call it 2. That is to do the classic way of just initializing, but then you say, oh yeah, you can make it as a type, and you say, okay, this is going to be a type of 16 U8s or numbers or whatever, and you can say undefined, so this is going to be gibberish, but what you can do is you can say std mem zeros, and this is actually going to, zero init, right? This is zero init, and I think you need to say 08 U8, and I think, do you pass it like this? I can't remember. Initializes all fields of the struct with their default value. Okay. Or zero values if no default value. If the field is present. This is for about a struct. You can zero init a struct like this with an std mem. But zeros. Zig users are encouraged to explicitly initialize all fields. I think you can do this by having a U8. Yeah, something like this. 16, pass the type of U8, and then maybe do this instead. Something like this. Is this going to work? Let's try to use it. What does it complain about? Value of type. Okay, no, it doesn't complain. Yeah, there it is. Okay, so you can also define it like this, which is actually longer, right? Getting 16 zeros is actually longer than just doing this. But yeah, I kind of like it. I kind of like this weird, quirky way of initializing. Okay, so there we go. Oh yeah, by the way, slices. Oh damn, I didn't even show slices. Slices are basically like fat pointers, as they would call them, which is a pointer to the start and a length. So, but the way you do a slice in Zig is that you define it with this. So this is a slice. There's a difference between a slice, right? If you say this and you say array, an array has a size inside the square brackets. So array has a size, slices don't have. And this is a bit confusing in the beginning. I was confused a bit in when I started, because I didn't know that these are actually slices, because they look like arrays to me. But yeah, there's nothing in between. So it's a slice. And what you can do is you can actually grab a slice of, for example, I can take R init to zeros if I do that, but I do need to do a put an ampersand in front because it's like grab a slice. That's what it means of array init to zeros. And now I can actually use this slice. What it does is this is basically a pointer to this array, right? But it also knows the length. So I can, instead of that, I can use this. So it's like I'm referencing this array in this slice. And there we go. It's the same thing. But the cool thing about slices is, of course, they don't need to be the full length. So you can just take you can take 0 to 2, right? This is going to be, okay, let's actually not initialize it to zeros. But I'm actually going to do init to zeros. And I'm going to capture, this is how we do a for loop with an I, by the way. And I'm going to set this to, by the way, yes, I also need to pass it as a slice. And I'm going to need to use a value as a pointer, if I remember correctly. And then I can grab a pointer and I can say this is equal to 1. Oh yeah, right. This is a value actually. This is how you do it, if I remember correctly. Okay, so yeah. Unsigned expected type U8 found U size. Right, because this is a U size. I need to cast it into a U8. Let's see what happens. Unsigned expected type found U8. Oh, maybe this is unsigned 8-bit int cannot represent all possible. But this is a U size. Maybe they changed something about this, because this is this an old version? Ah, I think this is something that differs from the old version to new version. I need to look into the changelog of Zig changelog. I remember there was something about release notes. Yeah, in 0.11. Well, how am I going to find it? Range. What is this called? Ranges for. Ah, there it is. Expected equal. Okay, so it does. You can use an unbounded range since vowels provide length. Right. So the array actually provides the length, which is good, yeah. But why is it complaining about this? Expected type U8 found U size. It is supposed to be U size. You can have multiple captures of any size, any kind. Oh wow, you can actually provide a. Okay, this is a new thing. This is a new thing, which I didn't know. The for loop is weird. So you can actually provide it with two arrays, even the same one, and then for one you could have a const and you could have a mutable reference as well. Interesting. But for some reason it doesn't let me do a 0 dot dot. Okay, look, I'm not gonna do this. Instead, I'm just gonna increment myself. I'm just gonna do a for loop of r_init. No, wait. Do I want to do an r_init to zeros? Yeah, why not? But it's not r_init to zeros anymore. I will need to rename that. Let's just keep the name for now. Okay, so this is going to be the value. I need to grab a slice, and this is going to be a pointer as well. And then I'm going to change the value of it to, I'm going to just create an I and increment it every time. Zig doesn't have plus plus, by the way, so I plus equals works. Okay, so this should work. Now I want to have an array of like 0 to 16. That's basically what I want. Am I having I anywhere? No. Okay, let's perhaps I should add a scope so that I don't mess with everything. And this string is above here, and this is string 4. Let's put all the strings into a separate scope. There we go. Okay. And it still doesn't work because variable of time comptime int must be const or comptime. Yes, it is this thing. I'm going to make this a U8 explicitly so that I can assign it to the value of my U8s. Expected type U8 found const r_init to zeros. Slice. Oh, interesting. So it doesn't allow me to get this because it is a const pointer of 2 U8s. Oh, right. Because I'm grabbing a pointer to this already. So I think it's just this. Let's see. Am I mistaken? No, that's it. Yeah, perfect. Great. Slices are great. Okay. So as you can see, I grabbed a slice with a range of 0 to 2. And if I output this slice, interestingly, both elements are 0. How is that possible? I am actually changing them here. Interesting. Oh, I'm not incrementing I. I totally forgot about this. What happened to this line? I wonder. Okay. Come on. Again. There it is. Yeah, we see that the first two elements are 0 to 2. 0 to 1. If I just grabbed 4 to 8, it would be 4, 5, 6, 7. There you go. And this is what essentially slices are. So they allow you to get a piece of an array from one element to the other. And it uses this kind of a syntax where you can grab, if you just had 4 dot dot, it will get from 4 to the end, as we can see now. There we go. We have 4 to 15. Perfect. And that is what essentially slices are. And by default, you can coerce strings to slices, as I have already shown, Comptime strings, so that you can have const, something as a u as a const u8, and then you can define it as something something, right? Something something. And there we go, it works. So yeah, if you define it as a slice, this string is actually somewhere in memory, right? It is somewhere in the program memory, and you can just get a slice to it and use it, pass it into your other functions, and yeah, it's basically it's basically exactly the same as char star and const char star in C, right? Because you can make it anything, and you can just grab it from a string literal. This is what I meant. I forgot the name of the literal. Yeah, string literals are saved in a separate part of memory. So yeah, that's slices, and it's pretty cool. There we go. Next feature, which is pretty cool, is packed bools. Well, or packing structs as well, but packed bools are kind of the coolest thing. What you can do there is, well, my main is now getting really big. Let's make a struct that has, and let's call it, oh yeah, that's not how you make struct in Zig. This is how you make a struct with in Zig. And I'm going to call it flags. And yeah, you could have, you know how in C++ you have a flag, and you have some flags which are, you want to set every bit. And what you would do is you would have an int, and you had to have flags, and then you would define them as like, well, my flag, right, is 0, 1, and my flag 2 is the next one, and stuff like that, right? And then you have to do flag arithmetic for that. Well, in Zig, this is actually something that compiler does for you magically, and you can do that by simply, as you would in basic, primary school programming, you would do by having a set of bools. And here's the thing. If I define, let's have a few flags. I don't know, it could be is static. I could call it something render. I don't know. Should you render it? I don't know, what could be movable or something like that. What else can we do? Is breakable, whatever. Computable. Collidable. I don't know, some kind of a set of flags that you want to add, right? And well, let me actually initialize them to false, just so that I don't have to initialize them explicitly later. And here's the thing. what is this? What are these bools? Bools are usually represented as bytes. And what is actually the size of bools? Okay, let's make a new scope. Oh shit, not here. Here. And I'm gonna say log info bool size. What's the size of a bool? Size of bool. And also, what is the size of my struct? Flags, which I call flags. So flags, what is the size of it? Whoops. And use the argument in info bool size. Oh yeah, of course. Again, I forgot this. There's another of these transitive failures. Okay, so there you go. What is the size of a bool? 1. It is 1 byte. And what's the size of flags? It's 6 bytes. It makes sense because it has 6 bools, right? And when we set each of these bools, I can set it with, I can create a new instance of flags. Let's call it flags. And I can set render true, I don't know, is breakable true, and everything else remains false. But here is one cool, very, very cool feature of Zig. You can actually pack a struct with a simple packed keyword. And what this does, let's rerun this code. Let's rerun this code again. What is the size of a flags? 1. Suddenly, it becomes 1 byte. Why is it 1 byte? It is 1 byte because each bool has now become a bit. This is a bit, this is a bit, this is a bit. And there's 6 bits, so it's less than a byte. If I would add a few more bytes, I don't know, I could do A, false. B, false. So now it has 8 bits. And if I would add another one, right? If I would add another bool, let's see what happens now. Look at that. Flags have become size 2. And here is the interesting thing. All these have essentially become flags now. And when you actually set them over here, when you actually set them in code, what actually gets compiled is a flag operation. It's like a bit cast. So that is why this is super cool. You never have to do bit casts again. I hope I don't need to. In C++, I actually have a little utility for solving, like setting bits and yeah, it's crazy. But yeah, in Zig you can just use bools and pack them, and that's it. And talking of packed bools, which are used as flags, let me tell you that Zig can also do arbitrary sized integers, right? You have all heard of i32s, right? You have heard of i16s. You have heard of i8s, you have heard of u8s today, and, unsigned 8-bit numbers, unsigned 16-bit, unsigned 1 8, 2. It can go up to 1 to 8 usually in other languages. But in Zig, you can have U14. You could have U13, right? You can have arbitrary number for your integer size. And look at it. It builds, right? And it is limited, of course, by the size of this integer. So why is this even important? Why are U13, U7, U9? Why is that important? Well, of course, if you have a struct which is called, let's call it weird numbers, and it's a normal struct that has these, number 1 is some U7, right? Number 2 is U3, and number 3 is U13, right? It has these weird numbers, and oh, I forgot to put a comma at the end. And by default, they will always be sized up to the closest byte, right? Or the closest aligned value. I don't think U13 is actually going to be 3 bytes. I think it's going to be 4 bytes. I'm not sure. But yeah, this is going to be 1 byte. This is going to be 1 byte. This is going to be probably 4 bytes. Let's see the size of it. Let's see the size of weird number. Weird numbers size. Weird number size is actually 4. Yeah. Alright, because this is actually 2 bytes. It does make sense. Okay, so what is actually, what if I put U17, right? Because U16 is 2 bytes. There we go. It is actually 8. So it has actually aligned it to the highest. Yeah, it is not like you'd think it's 7, but it is 8 because it aligns to the next power of 2, basically. So this is not going to be a this is going to be a U32 basically. So this aligns with U8, this aligns with U8, and this is going to be a 32-bit sized. But here's what is interesting. The interesting thing is if you put a packed keyword on it, now it will always resize exactly into the bits, right? There's not going to be any padding in between. And if I run this, let's see what the size is now. The size is 4 because that is how much it fits in, right? 7 plus 3, 10, and plus 17, that is 27. 27 fits in 4 bytes. Yes, it fits into 32 bits. Yeah, so that is a very useful feature when you have flags. When you need less precision, you can pack a lot more memory. And this is very, very nice. I really like this idea. Okay, anything else? Of course, yes, packed bools. Talked about them. Arbitrary size ints. Okay, pointers, captures. I did actually talk about captures, right? Because you have these straight brackets. I could say that I've talked about it. I did actually mention that there's no constructors and destructors and no operator overloads. But, yeah, each of these things are actually worth mentioning. And I'm kind of starting to get tired. I do want to go to sleep. And I didn't even think that I would only be able to show half of these things. How long is the stream going on for? 2 hours. Yeah, this is definitely not happening. So I can just remove this. Okay, I don't know. Should I go on? Optionals and errors. Maybe I do it tomorrow. Also something late in the night. But yeah, seems like so what do others think about Zig? Any other thoughts so far? Let me think if I can show anything else. Yeah, this does require captures. Maybe I can just say about pointers. Oh yeah, no, I can't actually because that requires thinking about optionals. Yeah, maybe I'm going to end here and go to sleep. And then continue, not tomorrow, but maybe some other day. Yeah, it would be fun starting to create the engine in Zig with all the optionals and errors. Yeah. I did open an array list to look at it. Okay. Yeah, I think I'm going to end it here because I don't have enough power to talk anymore. So I'm going to end here and continue some other day. Maybe start a little bit earlier because right now it's 2 a.m. here, 15 to 2 a.m. And that's, yeah, and I'm starting to slow down. So yeah, next time, maybe a bit earlier. And hopefully I can finish this list and then go on actually working on Zig, on the engine. Drawing some triangles. Okay, so see you next time. I hope you enjoyed a little journey into Zig, showing some cool Comptime features, arrays and slices, packing variables. Yeah, it's all pretty cool. Can't wait to actually use it in the engine. And there's quite a few more things to talk about. So yeah, see you next time. Bye bye.